Hello everyone, welcome to my class. In today's class, I'd like to cover calculus with parametric curves. Let me start the class right away. Quick recall. We know the parametric equations of a curves are of the form x equals to function of t and y equals to function of t, and it is coming from some interval. So the questions we used to answer in this section is how to define calculus on the parametric curves. That is, how to define derivatives, how to define integrations, how to define arc length of parametric curves. So first, let's talk about the derivatives, means let's talk about the tangents. That's better. We have the equation of curves in parametric form as x equals to function of t and y equals to function of t. So let's take the derivative with respect to t, then dx or dt becomes f prime t, dy or dt becomes g prime t. So the slope is dy over dx equals to dy over dt over dx over dt. This equals to g prime t over f prime t. And our slope is a function of t. And for concavity, let's take the second derivatives, or let's take the derivative of this slope. So then this is written as d2y over dx square. This becomes d over dt of dy over dx all over dx over dt. Quick example. Find the slope of the unit circle x equals to cosine t and y equals to sine t at t equals to pi fourth. Solution. Slope of the circle at t equals to pi fourth is dy over dx evaluated at t equals to pi fourth. So then use this formula. So g prime t means y prime over f prime t means x prime. That means derivative of sine t over derivative of cosine t. We know derivative of sine t becomes cosine t, and derivative of cosine t becomes a negative sine t. Evaluate at t equals to pi fourth. And in the next step, this minus is here. So cosine pi fourth is 1 over radical 2, and sine pi fourth is 1 over radical 2. So this number cancel out, so we only have negative 1. So the slope of the unit circle at t equals to pi fourth turns out to be negative 1. Awesome. Now let's move on. Next, let's talk about finding the areas, means finding the definite integrals. Oops. Great. So for t between a and b, we have x equals to function of t. So the derivative is dx equals to f prime t dt. So just take the implicit derivative here. And we have y equals to gt. Thus the area is a equals to definite integrals from a to b y dx. This becomes definite integrals from a to b y gt, dx is f prime t dt. Great. Quick example. Find the area of the semi-unit circle. So the equations are x equals to cosine t, y equals to sine t, and our t lies between 0 to pi. So only upper half of the unit circle. Area. The formula a equals to definite integrals a to b y dx. Our a is 0, b is pi. So next step, definite integral 0 to pi, y is sine t, and dx is the derivative of cosine t turns out to be negative sine t dt. This equals to, next step, pull this negative outside, and definite integral 0 to pi as it is, multiply sine t times sine t is sine square t. Then use the trig identity. Sine square t equals to 1 minus cosine 2t over 2 and dt. Next step, minus as it is, pull 1/2 outside, then integration of 1 becomes t, minus integration of cosine 2t becomes sine 2t over 2. Put limit t equals 0 to pi. And the next step, this minus 1/2 as it is, put t equals to upper limit of pi, and sine 2 pi is 0. And when you put t equals to 0, all 0. So that means we have by half. Great. Now let's move on. Arc length. For t between a and b, the formula to finding the arc length is L equals to definite integral ds. So this is the formula we found in chapter 8, where ds equals to under the radical of dx over dt outside is square plus dy over dt outside is square times dt. Then this can be written as definite integrals from a to b under the radical f prime t square plus g prime t square dt. Awesome. That makes sure that the curve traverses only once as t increases from a to b. Quick example. Find the length of the unit circle. And the solution is L equals to, by formula, definite integrals a to b ds. My a is 0, b is 2 pi. So in the next step, definite integral 0 to 2 pi under the radical dx over dt square means sine square t plus dy over dt square is the sine t derivative is cosine t square outside dt. We know sine square t plus cosine square t is 1, so radical 1 is 1, so we only have 0 to 2 pi dt. This turns out to be simply 2 pi. Great. Let's move on. Next, let's talk about surface area. So for t in between a and b, the surface area S equals to the definite integrals 2 pi radius times ds. So for surface area, our integral is with respect to arc length. This can be written as definite integral a to b 2 pi y ds if we rotate the region about x-axis, or definite integral a to b 2 pi x ds if we rotate about y-axis. So only the radius is different here. So rotation about x-axis, radius is y. Rotation about y-axis, radius is x. Great. Quick example. Find the surface area of a sphere of radius 1. So that means rotate semi-unit circle, x equals to cosine t, y equals sine t, about the x-axis. So solutions. So solution S equals to definite integral 0 to pi 2 pi radius times ds. Our radius is y. We are rotating about x-axis. This equals to 0 to pi 2 pi. Y is sine t. So this is sine t. And ds is under the radical dx over dt square plus dy over dt square. So dx over dt turns out to be negative sine t. Then is square, so that negative goes away, so simply sine square t plus dy over dt square means derivative of sine t turns out to be cosine t, so cosine square t dt. Again, we know sine square t plus cosine square t is 1, so we have in the next step 0 to pi 2 pi sine t dt. Then let's take the integrations. This 2 pi pull outside the integral. That's a constant outside. And we know the integration of sine t turns out to be negative cosine t evaluated t equals to 0 to pi. Then cosine pi is minus 1, so this minus minus plus, so plus 1, the 2 pi as it is. And minus from formula, so this is plus, and cosine 0 is 1, so we have answer is 4 pi. Great. Now let's do some more examples. Example 1. Find the equation of the tangent to the curve at t equals to 1, and the given curves in parametric forms are x equals to t cubed plus 1 and y equals to t to the power 4 plus t. Great. So let's begin the solutions. Here, t equals to 1 corresponds to the point here x is 2 and y is 2. Then I assume this point is x and y1. So to find the equation of tangent line, we do need two informations. One is a point. Now we have. Second, we need a slope. So next, let's find the slope then. So the slope formula is dy over dx equals to dy over dt all over dx over dt. So next step, in my numerator, find the derivative of y, which turns out to be 4t cubed plus 1. And in the denominator, find the derivative of x, which turns out to be 3t squared plus 0. Awesome. And put t equals to 1. So when t equals to 1, it turns out to be 5 over 3. Great. So we have a slope, we have a point. Then the equation of tangent line is using point slope form. Y minus y1 equals to slope times x minus x1. It turns out that y minus 2 equals to slope 5/3 x minus 2. Then simplify. It gives us the equation of tangent line is y equals to 5/3 x minus 4. I hope this computation makes sense to you all. Great. Now let's move on. Similarly, let's do example 2. Find the first derivative and second derivative for the curve given by x equals to t cubed plus 1 and y equals to t squared minus t. Next part, for which value of t is the curve is concave up. Now let's begin the solutions. By formula, dy over dx equals to dy over dt over dx over dt. And dy over dt is 2t minus 1 over dx over dt is 3t squared. That's the one answer. Here I distribute my denominator to each of these terms on my numerator. Next, let's find the second derivatives. Again, by formula, d2y over dx squared equals to d over dt of d over dx all over dx over dt. So we found d over dt is already here. Now let's take its derivative. We use the quotient rule here. It turns out to be this terms, negative 2 over 3t squared plus 2 over 3t cubed. For instance, the first part is keep 2/3 as it is, and the derivative of 1 over t is minus 1 over t squared, which is here. Great. And the denominator is dx over dt. Here, dx over dt is 3t squared. And now simplify this fraction. It turns out to be 2 times 1 minus t over 9 t to the power 5. Great. And the final part of the question is, for the concavity, the curve is concave up when our second derivative is positive. That means this result is positive. So set 2 times 1 minus t over 9 t to the power 5 is greater than 0. So that means 1 minus t has to be positive. So from there, our t lies between 0 and 1. When t lies between 0 and 1, excluding the endpoints, our curve is concave up. Great. Now let's move on. Example 3. Find the area of the curve given by x equals to t minus sine t and y equals to 1 minus cosine t, t between 0 to 2 pi. Awesome. Let's begin the solutions. Now by formula, the area A equals to definite integral a to b y dx. Here's our a is 0, b is 2 pi. So next step, definite integral 0 to 2 pi. Y is 1 minus cosine t times dx. Our dx turns out to be, take the derivative here, dx equals to 1 minus cosine t times dt, which is here. Great. So in the next step, the definite integral as it is, so FOIL this 2 factor. It turns out to be 1 minus 2 cosine t plus cosine square t. And we know the identity. Cosine square t turns out to be 1/2 times 1 plus cosine 2t. So let's use this formula here. Then next, let's take the integration. So here, so integration of 1 is simply t. Negative 2 cosine t becomes negative 2 sine t, plus pull 1/2 outside, and integration of 1 is again t, plus integration of cosine 2t is sine 2t over 2. Put the value t equals 0 to 2 pi. Now simplify these expressions, substituting t equals 2 pi and 0, and it gives us 3 pi. Awesome. I hope this computation makes sense to you all. Now let's move on. Example 4. Find the length of the curve given by x equals to et minus t, y equals to 4 times e to the power t half, t from 0 to 2. Great. Solutions. So here, let's find the derivative. Dx over dt turns out to be, derivative et is et minus t derivative is 1. Similarly, derivative of y turns out to be 2 times e to the power t over 2. So here we use a chain rule here. So 4 as it is, derivative of e power t over 2 becomes e power t over 2, and then times 1/2. So that 2 cancels 4. So we have 2 times e power t over 2. Then square and add these two equations. It turns out to be dx over dt outside is square plus dy over dt outside is square. Turns out to be et plus 1 outside is square. Great. So by formula, that's better, by formula, arc length L equals to definite integral 0 to 2 of et plus 1, because our arc length formula involves the radical here, radical of this expression. So radical and this is square cancelled. So we only have et plus 1. I hope this makes sense to you all. The next step, let's take the integration. Integration of et is itself, plus integration of 1 is t. Put t equals 0 to 2. Then it turns out to be e square plus 1. Awesome. Let's move on. Now, example 5. Let's compute the surface area generated by rotating the curve about y-axis. The given curve is x equals to et minus t, and y equals to 4 times e to the power t half, t between 0 and 1. Solutions. So by example 4, that's the question same as in example 4. So we have what we have ds over dt. So this expression, we have et plus 1 is square. Thus, by formula, surface area equals to definite integrals a to b. Now a is 0, b is 1, 2 pi radius ds. Radius is x because we are rotating about y-axis, and ds will be from here. So in the next step, pull 2 pi constant outside, definite integral 0 to 1. Radius is x, x is et minus t, this is here, and ds is et plus 1 dt. Great. So now next step, let's FOIL these two factors first. So 2 pi as it is, definite integral as it is. When you multiply et minus t times et plus 1, then this turns out to be e to the 2t plus et minus tet minus t outside dt. Then we can integrate term by term. So we can integrate e to the 2t easily, et easily. So for this terms, the integration of third term here, which is t times et, we have to use integration by parts. So then it turns out to be in the next step, 2 pi as it is, integration of e to the 2t becomes e to the 2t over 2, plus as it is, integration of et becomes et, then minus, then using integration by parts, the integration of t times et turns out to be tet plus et. Also I multiply by this minus. And the last term is integration of t becomes t squared over 2. t equals 0 to 1. I hope this step makes sense to you all here. So please use IBP separately and you'll get this value here. You'll get these terms here. Great. Now let's move on. So in the next, put a t equals to 1. Then here, so 2 pi as it is, e square over 2 plus e, I'm putting t equals to 1. Then minus, this is 1 times e, so simply minus e, plus e, minus 1/2. To put the lower limit, put minus, so this minus coming from formula. Now put t equals to 0. T equals 0 means e to the 0 is 1, 1/2. Here, e to the 0 is again 1, so then minus 1. This part becomes 0. This part becomes 0, so only this term, again, minus 1. Now add and subtract, then your final answer turns out to be 2 pi times e square over 2 plus e minus 3. Great. So we finished this sections 10.2. Thank you.